All right, let's talk about a fundamental thinking error, a little glitch in our mental software that affects pretty much all of us, from the way we play simple games to how we approach the highest levels of science. And it all starts with a little game.
So, let's play. Imagine a big group of us, and we all have to pick a number between 0 and 100. Now here's the twist. The winner is whoever picks a number that's closest to half of the average of everyone's guess. So, what number would you choose? Seriously, pause here for a second if you need to. Lock in your answer. Got it? Okay, so let's break down how you might think through this. The simplest way, what we can call level 0 thinking, is just to throw a random number out there. But then you get to level 1. A level 1 thinker says, okay, wait, most people are just going to guess randomly, so the average will probably be around 50. Half of 50 is 25. I'll guess 25. Smart. But then a level 2 thinker comes along and thinks, hold on, if everyone is smart enough to do that, then they're all going to guess 25. So the new average will be 25. I need to guess half of that, which is 12.5. You see where this is going, right? This chain of logic could keep going and going, all the way down to 0.
But here's the really fascinating part. When economists actually run this experiment with real people, they find that we don't follow the logic all the way down, not even close. Most people are level 1 thinkers. They guess around 25 or 35. A smaller group makes it to level 2, but almost nobody keeps going. It's like our brains do 1 or 2 steps of logic and then just stop.
Now, there's a fancy name for this process, iterative reasoning. It just means you take the conclusion you just made and you feed it right back into the beginning of your thought process as a new piece of information. It's a mental feedback loop. Your first answer, 25, becomes the new problem you have to solve.
So why do we stop? Why is this so hard for us? Well, this quote from cognitive scientist P.N. Johnson-Laird gives us a massive clue. Basically, he's saying our intuitive brain, our gut instinct thinking, is really good at building one single picture of a situation, but it is terrible at updating that picture with new information, especially with the conclusion it just made itself. Our mental RAM gets overloaded. We draw our conclusion, and then we're done.
Okay, so our brains have a short thinking horizon. Big deal, right? It's a fun fact for a party game. Well, this is where things get really serious. Because this little cognitive glitch doesn't stay in games. It scales up, and it shows how a simple mental shortcut can end up shaping our entire world.
Our tendency to stop after one step makes us fall in love with simple, linear cause and effect stories for everything. We want to see the world in straight lines. A leads to B. But the world, and especially our own biology, isn't a straight line. It's a tangled, messy, complex web. So what happens when this straight-line error becomes the main way of thinking in a field as vital and complicated as medicine? It basically creates two totally different ways of seeing the world. On the left, you've got the traditional view, built on that straight-line thinking. It craves certainty. It assumes most people are clustered around an average, like a classic bell curve. And its favorite tool is the big, randomized controlled trial. But on the right, you have complexity science. It starts by assuming the world is uncertain. It knows that in living systems, outcomes often follow a long-tailed distribution, where wild results are more common than we think. And its focus isn't the average, it's the individual.
And this love affair with the simple, linear model has led us to build an entire system for deciding what's true in medicine. A system that has a massive flaw baked right into its foundation.
If you've ever dug into medical research, I guarantee you've seen this, the evidence pyramid. It's the classic model. And sitting right there at the very top, the peak, the so-called gold standard of proof, are randomized controlled trials, RCTs, and meta-analyses. This pyramid is the perfect, beautiful product of that level 1 straight-line thinking.
But just how gold is that gold standard? Well, when a study finds a statistically significant result, that usually means its p-value is less than 0.05. And all that means is that the result would not have happened by chance more than 1 in 20 times. 1 in 20. That is a long, long way from the ironclad certainty we think we're getting, isn't it?
This uncertainty leads to this absolutely shocking conclusion from the famed epidemiologist John Ioannidis, who flatly stated that most published medical research is wrong. How could that possibly be? It's because the results from these huge studies often aren't repeatable. An intervention might work for the average person in a super-controlled trial, but then it fails in the messy real world because it totally ignores the complex, non-linear reality of every single individual.
So, if the pyramid we've all been taught to trust is flawed, what's the alternative? It means we have to stop looking for these simple, universal, one-size-fits-all answers.
It means we have to start embracing the messy, complicated, but wonderful truth of how individuals actually work.
And this brings us to a radical, powerful idea, flipping the pyramid completely on its head. This is the inverted pyramid of evidence, and it argues that when you are dealing with one specific, unique, complex human being, the entire hierarchy of what counts as valuable evidence is the exact reverse of the traditional model.
So why flip it? Well, think about it. Every single one of us is what complexity scientists call a complex adaptive system. The average result from a massive trial tells you almost nothing about how your unique system is going to respond. So for you, the most powerful evidence might actually be an N-of-1 study, a case report about someone just like you, or even just your own direct experience. From this point of view, those big RCTs, they provide the weakest, most general guidance, not the strongest.
Now, in this new view, it's not that some studies are bad and others are good, it's that they all have different jobs. An N-of-1 study is for telling a doctor if something works for this person sitting right in front of them. An RCT is still really useful for studying a simple cause and effect in a generalized average group, say for discovering a brand new drug. But it's just one piece of a much, much bigger and more complex puzzle.
And, this isn't really a new idea. It's actually a return to a timeless principle of medicine, captured perfectly by the famous physician William Osler. The good physician treats the disease. The great physician treats the patient who has the disease. The disease is the abstraction, the average. The patient is the complex, unique reality.
So what's the big takeaway from all this? It's really about a new way of seeing not just evidence, but the very nature of the problems we're trying to solve.
That thinking error from our little game, that short horizon, that tendency to stop after just one step, it isn't some harmless little quirk. It's scaled up to create an entire scientific culture that is far more comfortable with simple, clean averages than it is with messy, complex, individual reality. We built the evidence pyramid because it matched the simple way our brains prefer to work.
And that leaves us with a final and maybe a little unsettling question. If this straight line error is so deeply hardwired into our thinking that it could shape the very foundations of medical science, where else is it at work? In our politics? In our businesses? In our own lives? Where else are we applying level 1 thinking to a level 3 world and not even realizing we're doing it?